Hi, this is presentation about AI Interior Advisor. This is our content, and let's start with the motivation. The people's interest in interior decoration has increased due to COVID-19. And people care more about home furnishing, which means decorating their room by themselves. And in these circumstances, we plan to make AI Interior Advisor to help the people with no knowledge of interior design to decorate their house easily. This is our objective. We're gonna collect the three different data. First, item list of the user-owned items. And second, room image. Third, item images. With these data, we're gonna recommend the interior items tailored for your room style. And then we show the recommended items on our website. This is our framework of our model. We're gonna utilize the both collaborative filtering and also content-based filtering. For collaborative filtering, we utilize the neural collaborative filtering model. And by using this, we can collect the trend and taste information of the user. And for the content-based filtering, we utilize the convolutional neural network. And by using this, we can collect the atmosphere of the room and characteristics of the items and harmony of each item. And next is the data collect process. First, for the room, we collect the room picture, about like 5,000 pictures for each 8 styles. But we finally used only 4 styles selected based on the accuracy. And next is the item collection. We collect around like 60,000 items, and we collect the picture and frequency of the user use for each room style, and user item paired list, and also the item informations. And next is a model structure of neural collaborative filtering. This is the technique of applying collaborative filtering to deep neural network, and the method of recommending items to similar users through our combination of items in the dataset. Since this model utilized the GMF and MLP in the same time, so each model complements each other, which makes higher performance. So this is the data structure of how the data works in neural network spectralization. So the input is the user item pair list, and the output would be the similarity between user and item. And since it uses the sigmoid activation function, the output range is 0 to 1. With our data, the accuracy was 0.53. And with this model, we build the recommendation algorithm like this way. First, the user input the owned item, and then predict the top 10 similar users based on square sum of input items for each users. And then predict the rank for all items based on square sum of top 10 users for each items. And finally, recommend the items for the top scored one.
Next is the convolutional neural network model. There are 3 models, but I will start with 2 simple models. Model 1 is a model that trains the room style with room images, and Model 2 is a model that trains the item styles with item images. Model structure. We performed transfer learning using a pre-trained model. We selected the VGG16 model by referring to several papers and used the places 365 weight because the input is a place. After repeated training with different parameters, we found that we get the best result when learning by freezing 3 out of 5 large layers. And since style is not an objective fact, we use the label smoothing technique to make the target a little softer to increase the accuracy. As you can see, the input is the room image and the target is the style, and from this model we got an output representing the room style. The accuracy is 0.5942. Model 2 is almost identical to Model 1, except for the weight. The input is an item image, and the frequency of use for each room style is used as a target after converting it into percentage. This model gets the output representing the item style, and using this model, we predict all the items we have and store the value in the database for recommendation. Initially, we created a recommendation algorithm with each two models, but the relationship between room and items could not be explained by learning with two independent models, so results was unclear. So we made the final third model. At first glance, the framework may seem complicated, but it is not at all. The input is room items pair image data, and both Model 1 and Model 2 mentioned above are used. First, the room image is predicted by Model 1 and the item images are predicted by Model 2, respectively. Second, compare each item output to the room output to exclude different style items. Third, compute the average of the remaining item output to get the overall style of the items. Finally, we set that value as the target and train the room image. In this model, the relationship between the room and the items was also learned by learning the room image with the new target. The structure of this model is the same as Model 1, and the input is room items pair images, and as described above, learning proceeds using the value obtained by predicting item in Model 2 as a target. This model uses item feature for room style training. Although the accuracy was slightly lowered, the recommendation became clearer than the too simple model. Next is the recommendation algorithm. When user input their own room and item images, Model 2 and 3 predict the output from images of room and each item, and calculate the average value of the item output to find the overall style of items. Then calculate the similarity between each output and all items in the database using the Euclidean distance formula. Finally, recommend items with the highest similarity to each output from room and from items.
This is the AI Interior Advisor demo video. First, press the start button, and then first you choose the picture of your room, and then please press the next. The next step is type in some information about the items in your house. You can search it through the name of the item and also for the company. And then you can start the analysis. And this is the result of our model, CNN. And this is the recommendation result with our model, NCM. We also use the filter function, and you can choose the specific category that you want to find. In this case, it's a mirror category. And when you press the button, then you can release the filter. And thank you for watching.
Next is web structure. The model was created using HTML and JavaScript language and Bootstrap, and the server was built with Flask, and data was transmitted using asynchronous communication technology, AJAX, and the database was configured with MongoDB. The demo video showed that the result was quite good, and 60% of actual users said they were satisfied with the result. Conclusion: we wanted to recommend tailored interior items using the user's room and item information. So we use both collaborative filtering method and content-based filtering method, built a new CNN model, and used an appropriate recommendation algorithm. As a result, we could drive meaningful recommendation list. Thank you.